Now we come back and see the elastic and inelastic. Okay, we're going to see the elastic first. Okay, elastic. Okay, you can see the diagram here. Okay, first is the elastic. Okay, the second diagram at the back, this one we call inelastic. What's the difference? Okay, we're going to see the elastic first. Elastic means, okay, first one, same like this one. Okay, the ball one, move to right. Okay, ball two, also move to right. And this one is before collision. Okay, one is a before, one is a after. Okay, example, I want to give some readings. Okay, example, this one is 1 kg, 2 kg. Okay, after that, I want to give the velocity. Okay, this one go to right hand side, okay, 3. Then this one is 2. MS, everyone. U1, U2. Okay, after collision, the velocity now will become 2. Okay, this one's a V1. Okay, after that, this one will become, okay, 4. V2. Sorry, if I give all, no need to do calculation. So I need to empty one of the readings. Okay, example, I empty this one. Okay, we do know. V1 we do know. So from here you need to find out what's the V1. Okay, so from here we need to put the calculation here. Okay, total momentum before and after must be the same. So the formula I create first, M1, U1. Plus M2, U2. Okay, this one is the equation. Then before then equal M1, V2, V1 plus M2, V2. Okay, this one is the elastic collision. That means before you are separate, after hitting you also separate. This one we call elastic collision. So we do the calculation. Okay, the 1 multiplied to 3, direction all go to right. So that means I take the right is a positive. Okay, now plus. Okay, I plus already. 2 multiplied to 2. Okay, then equal 1. V1. Okay, plus 2, this one is 2 kg. 2 kg times 4 become 8. Okay, so now this one is the equation. Now we go to plus. Okay, we go to plus together. 3 plus 4 becomes 7. Okay, after that equal V1 plus 8. Okay, so from here, what is the V1? So V1 equal, how many? 8 go here, -1. MS 1. Can you see the V1 you get negative? V1 you get negative means you are opposite direction. If the question never tell you they are moved here, they say I don't know. Okay, they just say, okay, V1 finally like this. Then they ask you, find the V1. So I get the answer. If I get -1 means now the V1 is moved to the opposite direction. So this one is one of the questions that they ask. Okay, so remember you make sure which part is a positive, which part is a negative. So final answer, if you get negative, then you're very clear. Okay, this one negative means what? This one negative means the ball finally, ball 1, they are moved in opposite direction with the others. Okay, so this one we call elastic collision. Okay, after I show you the calculation for the formula, you need to know characteristic. Elastic collision got what characteristic? Okay, all is here. Okay, number 1, they say both objects move independently at their respective velocity after collision. So that means after collision you are separate. You never stick together. You are moved by your own velocity. Okay, number 2, momentum is conserved. Why we say momentum conserved? Because we follow this principle. So this one principle means everything also conserve. Before, after must be the same. Okay, number 3, kinetic energy also conserve. So that means total kinetic energy here. After collision, the energy here also same. Okay? Means maybe number 1, first one you get less energy. Finally you get more already. But maybe number 2, first one you less. Then finally you gain. Remember, when you plus this one energy kinetic and plus this one kinetic energy must be the same. Okay. And the last one, total energy also conserve. Total energy means what? This one when starting you are moving, kinetic energy. Okay, when you hit, not just kinetic, maybe you got heat energy, you hit already. Then the heat energy to come out, sound energy to come out. That one we call energy also. So we call total energy. So from here, total energy for two situations, before and after, also same. So conclusion, for the elastic collision, all should be the same. Momentum, kinetic energy, total energy, all must be the same. Okay, so this one is an elastic collision. Okay, after one of the collision, here they show you the formula. Okay, remember the formula. So you go to highlight. So make sure this one formula you know. Then we try example 3. Okay, example 3, sure they're talking about an elastic collision because we learned elastic first. Okay, example 3. Okay, we go to understand the question first. Okay, they say a trolley of the mass 2 kg. After that, they're moving with the velocity 0.6. So we draw first lah. Okay, a trolley. The mass is a 2 kilogram. Okay, now they're moving with the velocity 0.6. So we do know lah, we just write 0.6. Okay, we do know direction, we take one direction only. And climb is a stationary trolley. So this one trolley A, now got trolley B. Okay, now the trolley B, velocity, initial velocity equals 0. Agree? Stationary, never move. So this one, the mass is how many? 1 kilogram. So this one is before collision. Okay, before the hit. Okay, now, they say after collision, the trolley of the mass 2 kg moving with the velocity 0.2. Okay, after collision, this one, A. Okay, the A, they move with the velocity, this one is final, this one U1, this one is V1, 0.2. Okay, we also do know the direction correct or not. Because final answer, you see it, is it the answer positive or negative? So from here, we just write 0.2 with the velocity. Okay, then what is the velocity of the trolley mass 1 kg after collision? Then they ask you, now, B, B what happens? Now the B, they ask you V2. Okay, like this one situation you will ask, is it elastic or inelastic? When you read the question, you understand already. Because first one they told you velocity is how many? Second one they told you there's a stationary. Then the third one they say after collision, okay, the trolley first one, they move in 0.2 velocity. Then what is the velocity for the B? They ask you the B, what is the velocity? Means finally, two objects must be moved separate. You move your own velocity, I move my own velocity. So this one is the elastic collision. Okay, now we create the formula again. Just now I showed you the formula. Okay, the formula is M1 U1 plus M2 U2 equal M1 V1 plus M2 V2. So this is the formula. So we apply all the things in. M1 is 2 kg. Okay, multiply with U1 0.6. Okay, M2 no need to write lah because there's a 0. No moving. Okay, after collision, M1 still the same, 2 kg. Okay, multiply 0.2. Okay, plus final is 1 kg. Multiply, okay, do know V2. So we put a bracket here. So from here you do this one calculation, then you find what's the V2 lah. So from here, okay, I just give you the answer. So you, the longest one, how to calculate, you depend on yourself lah. So this one is 1.2 equal to the, okay, this one is 0.4 plus V2. So from here, you get the answer. What's the answer for V2? We take 1.2 minus 0.4. So you get it, the answer is V2. Okay, right here. V2 equal 0.8 ms negative 1. Okay, now we go and conclude. Is it opposite direction or positive direction? Okay, here 0.8. Go negative or not? No. Still positive. Still positive means finally AB before and AB after move in same direction. So that means this one A move here. Then this one B also move here finally. Okay, understand? So this one is a elastic collision question. Okay? Then after finishing the elastic, I need to go to the second one. There's the inelastic and inelastic collision. Okay, then we start with the inelastic collision. Okay, inelastic collision, you can see the diagram here. Okay, the diagram here, first one, before collision, can you see the trolley is separate? Okay, after collision, can you see the trolley become stick together? When they stick together, this one situation we call inelastic. Inelastic means they cannot elastic separate, they are in means they stick together. Okay, so from here I can show the diagram here. The trolley A first, they're moving. So still M1, U1. Okay, plus another trolley B also move. M1, M2. M2, U2. This one is before collision. Okay, after collision, A and B, they are moved together, they lock already. Locked together. Example, one girl and one boy, when starting you are separate and move. Then finally you are hugged together and move. That one we call inelastic collision. So from here we find it. Okay, we don't have V1, V2, we just got one V. This one V we call it common velocity. Okay, common velocity. So from here we can combine the formula M1 plus M2. And this one is V. V is common velocity. Okay, when the question just say what is the common velocity, understood. This one is inelastic collision. Because inelastic just got one collision, one velocity only. Elastic we got two. So this one is one of the questions they can find out elastic or inelastic. You see the question, common velocity. Okay, so from here, okay, before that, separate. Final, join together. Okay, from here, before I start to do the calculation, we need to know the characteristic. Okay, the first one we talked already. Before collision, two objects separate. After collision, both objects combine together with one velocity. The velocity we call common velocity. Okay, number two, momentum sure conserve. Why? Follow the principle of conservation of momentum. Okay, number three is a special. Number three is kinetic energy. Not conserve. Okay, just now it's conserve, now it's not. Why? Okay, we see why. Okay, kinetic energy when starting, before collision, you move your own, I move my own. Okay, you plus together your kinetic energy. Finally, can you see A and B stick together? You tell me they move fast or slow? Sure, become slower because you heavy already. What? So this one kinetic energy sure become less. Okay, become less, the meaning is lost. Okay, when starting maybe it's 30 energy. So after this one kinetic energy just 20 only. Where's the 10? 10 lost already lah, as a heat energy, as a sound energy. So that one is a lost energy. But kinetic energy, when I'm just talking kinetic energy, before and after is not conserved. But if I say total energy. Conserve. Okay, total energy before and total energy after, say conserve. Because total energy, we're talking all energy lah. So in front when starting, you have got kinetic energy. When you hit already, you got 20 kinetic energy. Then plus 10 is a heat and also sound. Okay, before that you got how many? 30. All is kinetic. Okay, so this one become equal. Okay, so this one we call total energy conserved, but kinetic energy not conserved. Understand? So this one is what's the difference? Elastic and inelastic. Okay, we got two differences. One is before separate, after this one stick. Elastic is separate. Okay, another difference, kinetic energy. Kinetic energy is always not conserved for inelastic, but for elastic, conserved. Okay, so third one you can say about the formula. Formula is different. The formula from here, inelastic formula, M1 U1 plus M2 U2. Okay, equal M1 plus M2, then multiply VR. The formula also different lah. So example question. If I say the example question like this, okay, the first one, the A. Okay, again 1 kg. Then the velocity is 2, ms negative 1. Okay, now the second one I say, no, you are no moving. You are 4 kg. Okay, then the U2, this one is U1, this one U2, 0. Okay, after that you stick together. Then you stick together, you move with the slow already, then you move together with the 1. V cannot tell you. Okay, again, V I cannot tell you. Because V is one of the question. So V do know. Then they ask you lah, what is the V? When they stick together already. So from here we need to apply this question lah. Okay, M1 1 kg multiply with the U1 2. Okay, plus, okay, 0. Okay, equal M1 plus M2. So M1 is 1 kg, this one 4 kg 5. Okay, now V. Okay, we do know what's a V. So this one is a 2, then you have 5V. Now V is how many? V sure becomes slow because 2 over 5. Can you see? Kinetic energy becomes slowed down. So I say kinetic energy not conserved. So from here, this one is original, 2 ms and 1. Then finally, both stick together, the velocity becomes slow. 2 over 5. ms negative 1. Okay, you need to find out in decimal point, cannot write in fraction. So this one is an example question. Okay, everybody understand? Huh? So if not understand, you just stop a while, then you repeat again what I say. Okay, we can see example 4. Example 4 is one of the questions related with the inelastic. Okay, now we do the example 4. Okay, we go to understand the example 4 first. A trolley of the mass 1 kg. Okay, draw. A trolley of the mass is 1 kg. Okay, now they are moving with the velocity. So that's a U1, 6. Okay, collide with the stationary trolley. So now another trolley. So another trolley is a 3 kg. This is stationary, so U2 equals 0. Okay, now this all is a before collision. Okay, after collision, they say they stick together. So this one is a keyword. So when you read the question, you must read very careful. Keyword is a stick together. The question never stupid to tell you, oh, this one elastic, this one is an inelastic. No. Okay, you must understand the question. So from here they say stick together. Another keyword, common velocity. So that means this one understood lah. There's an inelastic collision. So from here after that they say they stick together. Then they stick together. Okay, 1 kg, 3 kg. Okay, then they ask you what is the common velocity. So from here we apply again the formula, m1 u1 m2 u2 equal m1 m2 m1 plus m2 v. Okay, m1 plus m2, not m1 multiply m2, m1 plus m2. Okay, so now we go and do the calculation. So this one is a 6 multiply 1, 6 plus 0. Okay, equal m1 plus m2. So 1 kg plus 3 kg, so become 4. Okay, after that v. Okay, so you need to find out the v. So v equal 6 over 4. So the answer is 1.5 ms. Okay, so that means final, both stick together, move with velocity 1 times 1.5 times 10 power of -1. See, easy slow down. First one is number 6. This one is nothing. And just stick together becomes slow, 1.5 already. Okay, so this one is a calculation for inelastic collision. Okay, the last one is explosion. So this one is a question I want to tell you about the fireman just now. Okay, explosion, you can see the diagram here. Okay, the explosion is the trolley when starting. Okay, when starting you see both is no moving. Okay, example for the just now, the horse. The water inside the horse, before you on the water, there's a nothing. Water and horse stick together. Yes or no? That one is explosion. Then when I just start, you find the water will move forward, but you feel another thing. The move you go to backward. That one we call opposite momentum. So this one situation we call explosion. Beside the example for fireman, we can say about the bomb. Okay, when starting the bomb before they go to explode, actually it's nothing. They are stationary, yes or no? When they start to explode, what happens? Explode, boom. That means one go to left hand side, another go another side, go another, everywhere also got. So mean this one situation means when they just start to explode, they go to everywhere. They go to everywhere. So when I do the calculation for everywhere, the momentum should be the same. Because some got positive, some got negative. When you plus together, the answer should be 0. So that one we call explosion. Okay, another situation. Okay, let me draw first. Okay, another situation for explosion is the pistol. Okay, pistol. I don't know how to draw. Okay, the pistol. Before that, the bullet and the pistol. Okay, stick together. This one we call before collision. Both are stick together, no moving. No moving, understood lah. Momentum should be 0 lah. Okay, after collision. The after collision means you are fire. Fire what happens? The bullet must be go forward. Okay, then forward we got forward momentum. At the same time, they show you create another momentum. This one another momentum go where? Must go to backward. So that's why now your pistol is recoil. Go to the backward. So that means when you just fire, don't say about your movie lah. Your movie fire is very simple. Take like this only. Don't have any action. Suppose you got big action. When you just fire, that means you must recoil, go to the backward. Your hand not simply hold like this. Your hand must be big, go to backwards. That one is called backward momentum. Because you create forward momentum, then you got backward momentum some more. So now this one situation, this one go forward, your pistol is go backward. Follow principle. Remember the principle. Total momentum before must equal total momentum after. Means before you are 0. Final also must be 0. Yes or no? So the situation is very surprised. Why you ask? 0. Then this one 0. Got move for. How come 0? The moving is opposite direction. Can you see? The bullet move here. And the pistol move here. Then you ask, hey, if you say opposite direction, how come the bullet and the pistol, they move, the speed is the same, eh? No, I didn't say the speed is the same. Remember the formula when after collision, separate, we never speed. M1, V1, M2, V2. This one is for bullet. This one for pistol. Okay. These two plus together must equal to 0. Why becomes 0? Okay, you see, bullet, pistol. Sure, one is the opposite direction, yes or no? Okay, example, I take this one opposite direction. This one V1 sure is a negative one. This one V2 is a positive. Okay, which one will go faster? Sure, the bullet lah. Bullet, the mass very lighter one, but go very fast. So this one V2 sure higher one. Agree? Then this one V1 sure less one lah. Yes or no? Okay, M1. The pistol sure heavier one. The mass must be higher. How about the bullet? Bullet, the mass must be lower. Can you see the arrow? One up and down. Pull back. Revert up, then the pull you come down, so become equal. This one also same. The mass of the bullet is very low. Then suddenly you go very fast. Then when you multiply together, okay, become constant again. So that means final, your answer should be 0. Because you got one negative. Okay? Example, this one I get, okay, negative 5. So you sure this one you get positive 5. Sure already. So final answer becomes 0. Okay, so this one is explosion. Okay, follow the notes here. We go through the characteristic first. Okay, first one they say before explosion, both objects stick together. Okay, before they stick together and also rest. Never move. Okay, after collision, both objects sure will separate. How they separate? Opposite direction. So that one is the characteristic for explosion. Finally, should separate. Then how to separate? Opposite direction. Okay, then momentum conserve. Why? Follow principle. Okay, the next one. Total momentum before sure is a 0. Agree. Because they say stationary, we're starting. So sure is a 0. Then total momentum after collision, how? Also must be 0, yes or no? Because before is 0, final must be 0. So they create the formula. Before 0, final M1 V1 plus M2 V2. Sure, one of the V is in opposite direction. So this one is an explosion. Momentum, the formula. Okay, we got collision, elastic, inelastic, the last one is an explosion. So from here we're going to see the example 5. Okay, let's see example 5. A boy, the mass is 60 kg. A boy. 60 kg. Okay, now a girl. Girl, okay, boy. A girl different, You wear the skirt. Wear the skirt. Okay, girl is how many kg? 40. Okay, now they are stand facing to each other on the skating ring. Okay, the girl will push the boy. Okay, sorry, when starting they stick together. After that they push each other. So the drawing should be together first. And boy, this one is a girl. Okay, they move together. Okay, so this one is a 60 kg. This one is 40 kg. Okay, now when starting, we'll move on. When starting, they say they are facing to each other for the skating ring. Okay, so that means when starting, they never move on. So this one's before 0. They don't have any momentum. Okay, after that, the girl will pushes the boy and move backward. So after that, the girl, okay, move backward and push the boy far away. So move backward with how many velocity become? V2. There's a 2. Okay? Then after that they say what is the, the girl push the boy and he move, not the girl, it's the boy. Okay, it's the boy move here with the V1 is 2. Okay, girl don't know. Okay, they push this one boy, the boy move another direction. Okay, then after that the girl also move another direction. Now that's the V2. So they ask you, the question asks you, what is the velocity of the girl? So this one is an explosion. When we're starting, they will move. So your final answer sure is a negative, because if you take V1 is a positive lah. Unless you take V1 is a negative, then the V2 should be positive. Okay, then we follow the formula and do the calculation. Equal. So V1, 60 kilogram, multiplied with 2. Okay, for the boy, plus the girl is 40, then V2. Then we do the calculation for V2. Okay, your answer, you got it, then is negative 3. Okay, negative stand for the girl move opposite direction with the boy. That one is the meaning. If you take the boy is a negative, this one sure is a positive one. So that means you take the positive, you don't need to explain lah. So if you take the negative, you need to explain where's the movement, where's the direction of the girl to move. So this one is the answer for the explosion. So from here you say move in opposite direction with the boy. With the boy. So this one is the answer. Okay. So we got 3 different things. So I want to do the conclusion for this all collision. We do the elastic and inelastic. So from your notes, they will do some conclusion about that. Oh no. Okay. So I just stop here lah. What's the similarity for the elastic and inelastic? The similarity is momentum conserved. Okay. Momentum is a concept. Don't care you are hit, stick together, or you hit, you are separate. So you get the momentum should be conserved. Number 2, your energy, total energy also conserved. Okay, so this one is a 2 similarity. And one more, the mass cannot change. Okay, the mass before after sure cannot change one. So now we got 3 similarity. Okay, now we're going to see differences. Elastic and inelastic, what's the differences? Okay, differences, first one is elastic, when they stick, when they hit together, they are separate. They never stick. Before separate, after hit also separate. That one is elastic. For inelastic is before that you are separate. After hit, you are stick together. That one is the differences. Okay, number 2 is a kinetic energy. Kinetic energy for the elastic is conserved, all conserved. For the inelastic, before and after is not conserved. So that one is another differences for the elastic and inelastic. So we just got 2 differences only. Okay, so from here the following should be the application. Application we uses for the momentum. So normally the application, the momentum we using as a explosion. You can refer your textbook, they got diagram. So I can show you here. One of the is a launching for the rocket. Launching for the rocket, they're using the explosion concept to explain. Okay, now we're going to see. Can you see one of the rocket, they move upwards, they go up. So they create another momentum also go backwards. So which one create first? Sure, it's a gas to create first. The gas produce hot gas, move faster, go to bottom. So that means at the same time, they create another high momentum, they go forward. So finally, the rocket can be launched upwards. So now we need to see the explanation. Before launch, the rocket is rest. Okay? Remember, explosion before. Or also rest, never move. They are stick together. Gas and rocket is together. Okay. So rest at the base of the launch pad with the 0 momentum. So during the launch, So you find a hot gas that moves downwards. So at the same time, they create another high momentum go upwards. So that's why the rocket can be moved upwards. Okay, this one is one of the example. So the following we got jet engine. So this one can come up for the process question. Process question, what's the meaning? Process question means one of the sentence, they just give you 4 marks. They ask you, okay, please explain. How come the jet engine can be functioned? By using principal conservation of momentum. So that means you need at least 4 points. You got 4 marks, at least 4 points. Don't just mention, oh, because of principle. Then finish. One sentence you think can take 4 marks. So from here, we need to explain one by one. I already label for you the number. Okay, let's see the first number. First number is A intact. Okay, A intact. Okay, forward. Okay, the first part here. Okay, A intact. Okay, that means they need to let the air go in first, suck in first. Okay, number 2, there's a compressor. The compressor must be here. Go to compress. Okay, compress what? Compress the air lah. Okay, after that, number 3, okay, compressor together where they go to compress together with the fuel. They must have the combustion chamber. Okay, the thing let them to burn. Okay, after that, number 4, after burn already, they got turbine blade. Turbine blade, they need to turn. Okay, turn, after that they generate the high pressure, high momentum. Okay, last one they got exhaust gas. Okay, burn already, then they got gas to produce out. Okay, now this one they move forward. Okay, move forward because the gas another opposite direction. So from here we need to explain one by one. Okay, first we go to A intact. Okay, A from the atmosphere, they will go in the engine. First one, the A must be go in. Okay, that means you got blade to absorb all the air go in first. Okay, number 2, after go in, where they go? Compressor. Okay, number 2, compress by the compressor before the force go into the combustion chamber with the high pressure. They need to compress all the air first before they go to chamber. Okay, this one chamber sure got the fuel. Okay, the petrol, the fuel almost together because you want to burn. Okay, burning you need oxygen, so the air must be go in. So number 3, in the combustion chamber, the kerosene is a fuel. They must burn gasoline with the compressor A. Okay, they must burn is very strong together with the A and also the fuel. Okay, after that, number 4 is the turbine blade. The hot gases that form after the force. Okay, turbine blade, they turn, press it and turn it, then they produce the hot gases. Then the hot gases, where they go? They're forced to come out from the nozzle. The nozzle must be small diameter. Small diameter, then they come out must be high speed. Okay, they come out here, nozzle. Okay, small diameter. Okay, after that they come out is high speed. Okay, when high speed understood, momentum should be high. Okay, so from here you see that ejected with the high speed exhaust gas create backward momentum. So from here they come out with backward momentum. Okay, at the same time, the last sentence you must bring the principle to come out. Follow the principle conservation momentum. The forward momentum for the engine also produced. Then finally what happened? The plane can be moved forward. Okay, so many steps. First, air intact. Then they compress in where? Combustion chamber. Combustion chamber inside is got what? It got kerosene. After that they burn, strongly burn. After that they produce the gas, hot gas. Then the hot gas go through the nozzle, come out with high speed. High speed means high momentum. So from here they create back momentum. So at the same time, follow the principle conservation of momentum. The forward momentum also create. Then finally, the rocket move forward. Okay, the plane move forward. So this one is an explanation. another one is a rocket. Okay, the rocket also same. Can you see I label one? Okay, one got two. One. One is a liquid hydrogen. Another one is a liquid oxygen. That one is the fuel. Okay, the fuel want to help for burning. Okay, let's see the explanation. Also same, almost the same. Must have the hot gas. Okay, first one, the rocket that carries about the liquid hydrogen and liquid oxygen. Then the maximum of the hydrogen fuel and oxygen they will burn. Okay, sorry, it's burn, not bomb. Okay, do the technician problem for typing. So there's a burn. Okay, after in where? In the combustion chamber. Okay, 3. The gases they form is discharged through the exhaust nozzle with a high velocity. Okay, after they burn, they produce the gas, it's a hot gas, then they come out with the high velocity. So number 4, since the exhaust gas process the mass and velocity, backward momentum is created. High speed, then they create the backward momentum is high. So number 5, again, according to the principle, after that, conservation, so the rocket, they gain the forward, or you say upward momentum. So they will move with upwards with the high velocity. So this one is the same explanation for the momentum. Okay?
We have ignition and liftoff of the United Launch Alliance Atlas V rocket with AEH.
Everybody, so recall back what we learned. First one, we learned about momentum. What's the formula? Okay, after that, we learned what's the unit. Then we do the calculation for the simple for our formula for momentum. Okay, remember momentum is a vector, so remember the opposite direction. Okay, after that I introduce for two collision, elastic and inelastic. So make sure to differentiate. Okay, number 3 is the explosion. Explosion is related with the object. When starting they will move, finally they are moved in opposite direction. Then after that I show you the two application. One is a jet engine. Okay, number 2 is a rocket launching. So these two also using the same concept. So at least for 4 points, need to explain by the 4 points. Okay, so I finished my lesson for the momentum. So later the lesson should be the tutorial. So what you need to do, you finish your tutorial first. So later I will upload again the tutorial lesson. Okay, thank you everybody. So please do the revision okay, in your house. Don't just play only. Okay, thank you everybody.